The strong nuclear force is based on gravity, and this is based on the primitive axiom about gravity. It states that gravity has a magnitude of space moving into protons and neutrons that is equal to the magnitude of time passing outward radially from each proton and neutron. This means really that the volume of a proton is equal to some amount of time during which space is withdrawn from the surrounding space. And that's what causes gravity. And then time is emitted by an equal amount to the volume. And that goes the other way, outwards. And that then causes the acceleration of nearby masses, because time is a derivative of the movement of the momentum of free space, which is the volume divided by the time constant. We can calculate this momentum as for each baryon as 7 times 10 to the minus 37th cubic meters per second. And we can calculate this time constant by using the formula shown on this website. And here it is, n, the number of baryons on the Earth, times the volume of a proton, divided by 5 nanoseconds, equals the height fallen by a rock in 1 second, times the area of the Earth, divided by 1 second. So this is just for a 1 second experiment. It turns out that the answer is 5 nanoseconds. If you want more math on this, you could go to this other website here, in which the calculus is shown, and the Newton's gravitational constant is derived using this type of thing here, so that then the strong nuclear force is based on those principles. Time is a new thing that is introduced into the strong nuclear force. And you can see more on this at the Impure Math here, .wordpress.com. And then also I wanted to show you that the reason is geometry. In the geometry of the nucleus, a cube is at the center of, for example, uranium or tungsten or something. So here's the cube, and these gaps here are places where gravity is changing into the strong nuclear force. The curvature of space is the radius of the proton here. And the curvature of time as it is emitted is a hydrodynamic concept. As inside the cube, for example, time is being emitted by 8 different protons and neutrons, but it can only be emitted out of small gaps, which there's only 6 of them. In fact, there's only 3 or so, I believe, 3 or 4. So that there's a increasing derivative of gravity. So, for example, the 4th derivative of time will be used to calculate the strong force, when also the curvature of partial derivatives, as change of time with respect to radius, the change of the x dimension with respect to the radius of this gap here, as the hydrodynamic flow. A liquid basically is flowing in, and time is flowing out in a condensed form near the nucleus. That's what makes gravity 10 to the 40th times stronger than normal. Those curvatures, those high derivatives of time.